Hi everyone, welcome back. In part 2 of our NFT series, we're building on what we did in the last video, minting and burning. By adding role-based access control, token URIs and token pause functionality, and finally we'll add token transfers in this video. If you haven't watched part 1 yet, pause here and check it out first. Right, the prerequisites. Make sure you have cloned the example repository or you have your own copy on your machine. You'll also need Hardhat with the Hardhat Ethers plugin, OpenZeppelin contracts opened in your browser, and a Hedera testnet account with your operating key configured in Hardhat config.js. Alright, step 1. Create and compile the Solidity contract. Let's start by creating a new file in our contracts folder called ERC-721 advanced.sol. This file will contain our advanced ERC-721 code. Let's go to the OpenZeppelin contracts wizard and create our contract. Select the ERC-721 contract option, change the name to My Token Advanced with the symbol MTK, and enable minting and auto-increment IDs. We also want the pausable functionality, so let's enable the URI storage. And lastly, to enable access control, go to the access control feature and select the roles option. This allows us to set role-based permissions for different features like pausing or minting. Copy the generated code and paste it into your new Solidity file. Let's compile our contract with the npx hardhat compile command. Hardhat's compile task will process only changed files for speed and output artifacts in the artifacts folder by default. Alright, that's done. Now step 2, deploying and minting a token. In step 2, let's create a new script called deployAdvanced.js in our scripts folder. This script grabs our deployer signer from ethers.js, gets a contract factory for My Token Advanced, and deploys it with the admin, pauser, and a random minter address. This means that a random account got a minting role for our smart contract. We will also later verify if our deployer address can't mint a token for the deployed contract. Cool. Now, let's deploy the contract with npx hardhat run. Reference the deploy advanced script for the testnet. Once your contract has been deployed, make sure to copy the contract address as we need it in the next steps. Next, let's attempt to mint a new token using our deployer account. The mint.advanced.js script uses the saveMint function to mint a new token. The function accepts a token receiver address and the metadata URI, as we've enabled the token URI feature. This URL links a metadata file to the token. Don't forget to replace the contract address variable with the contract address you have just copied. You can execute the script using the npx hardhat run command. When we attempt to mint, it fails because our deployer isn't the minter role. We've set the third constructor argument to a random address. Step 3. Fix permissions and redeploy. Okay, let's fix the permissions. Now let's give the contract deployer all roles in the deploy advanced script. Then redeploy it by executing the deploy advanced.js script using the npx hardhat run command. Make sure to copy again the new contract address. Next, let's go back to our mint advanced script. Update the smart contract address and execute the script using the npx hardhat run command. As you can see, the command succeeds. We've minted the new token with ID 0 and the corresponding token URI is also printed to our terminal. Step 4. Pausing the contract. Okay, it's time to explore the pausing feature. With the pauser role set, we can pause the contract, disabling minting and transfers, which can be useful in emergency situations. Open the pause advanced script and don't forget to replace the smart contract address with the one you've copied. This script calls the pause function on the contract to pause all transfers for the contract. Execute the script using the npx hardhat run command. As we have the correct role, the token will be paused and its paused state will also be printed to our terminal. Step 5. Transferring NFTs. Finally, let's try to transfer the token to a random address. Open the transferAdvanced.js script and make sure to replace the contract address with your address. When we take a look at the logic, you can see that we first unpause the token, request the pause state using the paused function, and then we transfer the token with the token ID of 0 from the deployer account to a random address. And lastly, we verify if the random address actually received the token by checking its balance. Execute the script using the npx hardhat run command, and if the balance for the random account shows 1 in the terminal, congratulations, you've successfully transferred your NFT. And that wraps up part 2. You have now implemented access control, metadata URIs, pause functionality, and you've learned how to transfer a token. See you next time.